Okay? All right, now let me tell you about this. There's along with any complex number, there's what's called a complex conjugate. And here's how that works. For the complex number a plus bi, the so-called complex conjugate is a minus bi. A minus. So if I have a plus bi, a minus bi is called its conjugate. Now, how are those related? Well, they're very much related because the only difference is the sign between them, right? This one is a plus bi. A and b are just numbers. But then I have a plus. There I have a minus. Okay? So that's, if you want the conjugate, you just change the sign there. So if we're talking 4 plus 3i, what's its conjugate? 4 minus 3i. Now, if I have 6 minus 2i, the conjugate there, what about that one? Well, since I've got the minus, I change it to plus. 6 plus 2i. Yeah, so the example is plus to minus, but if it's a minus, it goes to plus. You see that. Now, what if it's negative 8 plus 7i? Well, now, notice what happens to a. A, nothing changes, does it? So even if it's negative, a doesn't change. It's just the b that changes. So what's the conjugate? Negative 8 minus 7i. Yeah, you don't change anything about it other than the b to the opposite sign. Okay. Now, why do I mention that? Well, one thing I can mention about it is, let's notice what happens. Let's just use these two. What happens when I multiply conjugates? Something very nice happens when I multiply the conjugates, and I'm going to use that to my advantage with what we're going to do next. 4 plus 3i times its conjugate 4 minus 3i. Let's notice what happens. FOIL that out. 4 times 4 is 16. 4 times minus 3i is minus 12i. 3i times 4 is positive 12i. And then 3i times minus 3i, what's that? Minus 9i squared. All right, so what happens is, what happens in the middle there? Those go out, don't they? 0. I've got a minus 12, and I got a plus 12. That's 0. So those are essentially wiped out. Now I have also, I've got the I squared there on the end, so that's minus 9 times a minus 1, isn't it? I squared is always negative 1. So I have a negative 9 times a negative 1, that's positive 9. So I have 16 plus 9, I have 25. Now what was so special about that? Well, the middle terms dropped out. And so what it is now, we note there, I don't have, even though I started with something that had I in it, does this have I in it? Technically, no, not really. It's just a real number. So anyway, that's going to help us with what we're going to do here next. All right? Question or concern? And that will always happen when I multiply conjugates like that. The middle terms will drop out, and I'll just wind up with this nice, regular, real number. Okay? All right. So we've added, we've subtracted, we've multiplied. What's left? That'd be divide. We even squared, but the same as multiplying, I guess. We need to talk about what we do with what looks like a dividing of complex numbers. What we're going to do is, well, let's title it this: simplify when you have A plus BI divided by C plus DI or something. What do we do if we have something here? It looks like I'm dividing two complex numbers, right? How do I, though, simplify that? Yes, we're going to use the conjugate here. For example, 8 plus 9i over 5 plus 2i. Like I said, I want to simplify this, and it's not technically dividing it, but here's how we simplify it. Turns out we can simplify this to be a complex number, just one single complex number, by what we do is we multiply by a conjugate, and the conjugate is of the denominator. Multiply by the conjugate of the denominator. Top and bottom. Going to multiply by the conjugate of the denominator. Let's see how that works out. So we have 8 plus 9i over 5 plus 2i. So I'm going to multiply by the conjugate of the denominator. What would be the conjugate of my denominator here? 5 minus 2i. 5 minus 2i. So I just multiply over on the other side there by 5 minus 2i. Now, to make this legal, kind of like we did with the square root, rationalize the denominator, we had to do the same thing on the top, right? So what do I multiply the top by? Very same thing, 5 minus 2i. Yeah, that's what makes this okay to do. All right, now, what is that going to mean? Well, look at this. Let me put some parentheses around here. What does it look like I need to do to the top and to the bottom? Couple of foils, yeah. Couple of foils here. Yeah, foil the top out, and then we're going to foil also on the bottom. All right, so if I foil the top, 8 times 5 is 40. 8 times minus 2i is minus 16i. And then do 9i times 5, 45i. And then 9i times minus 2i is negative 18i squared. And then on the bottom I have 5 times 5 is 25. 5 times minus 2i is minus 10i. Minus 2 times 5i is positive 10i. And then minus 2i times minus 2i is minus 4i squared. Now the reason for doing all that is, of course, it simplifies nicely. This will be, what, 40? Then I've got like terms on top of I, negative 16 plus 45i, 29i, positive. And then I've got, well, there's my I squared again. Whenever I have I squared, I want to change it over to negative 1. So what do I have on the end there? Positive 18, don't I? Negative 18 times negative 1, positive 18. Similar on the bottom happens, but even nicer, because what happens in the middle here? Yeah, the 10 i's cancel out. So I just have 25, but there's the I squared again. That's negative 1, so I have negative 4 times negative 1, which is positive 4. All right, well, there's two terms there I can combine. 40 and 18 is 58. So the top is 58 plus 29i. What's the bottom? 29. Which is a pretty good answer, but it simplifies even more because, as we know, this 29 divides both of those. So we'd have 58 over 29 plus 29i over 29. And what does that give me? Well, that's nice because 58 divided by 29 is 2. The 29's cancel here, so that's just 1i or I. 2 plus I is my final answer. So notice what happened is I went from this complex number over complex number and got to that, which is just a single complex number. And that's what multiplying by the conjugate there does. Okay? Let's try one more of those and See if the same thing happens. Let's try. Is that okay? Any thoughts or concerns more on that? Okay. Let's try this one. Eight minus I over 4 minus 3I. Simplify if we can. So now we're going to simplify that one. Well, I'm going to multiply by 4 plus 3I. Yeah, I'm going to do the conjugate of the denominator, which is 4 minus 3I, so the conjugate would be 4 plus 3I, but I have to multiply it also by the top. So if 8 minus I times 4 plus 3I on top, what's that going to be? 8 times 4 is 32. 8 times 3I is 24I. Minus I times 4 is minus 4I. And then minus I times 3I is negative 3I squared. Then do the bottom. 4 times 4 is 16. 4 times 3I is 12I. Minus 3I times 4 is minus 12I. And minus 3I times plus 3I is minus 9I squared. Well, that turns out to be what? 32 plus 20I, 24 minus 4I, right? And then there's I squared, so don't I have negative 3 times negative 1, positive 3? Positive 3 on the end. On the bottom, the 12 I's go out. 16 then, well, there's minus 9 times negative 1 again. It's positive 9, isn't it? So, combine these two. 32 and 3 is 35 plus 20I divided by 25. This one doesn't simplify quite as nicely. We can go ahead and divide each of those by 25 to get it in the A plus BI, but yeah, those don't divide nicely. That would reduce by 5, so that would be 7/5. This one would also reduce by 5 and get 4/5. So I'd have 7/5 plus 4/5 I. Yeah. So they won't always have nice whole numbers or integer A and B's. You can't get those. How about that? Any question or concern?